Alright, I'm going to do the minimization problem, a dual minimization problem. Alright, the problem is minimize c equals 10x1 plus 4x2, subject to 2x1 plus x2 is greater than or equal to 6, x1 minus 4x2 is greater than or equal to negative 24, negative 8x1 plus 5x2 is greater than or equal to negative 24, and then x1, x2 are greater than or equal to 0. That's like right here. Okay, so the first thing you do is put it into a matrix C. Okay, now when you're putting it into a matrix C, you use these numbers. So 2, 1, 6, 1, negative 4, negative 24, negative 8, 5, negative 24, and then you use the objective function, which is right here, and put that into our bottom row. Now, the next step is to find the transparency of A. So AT, the way you do this is you take your columns and put them into rows, like this. Okay. Now, we need to make this into a maximization problem. That's our A transparent. Now to make it into a maximization problem, we need to use change our variables to y's because you need to use different variables because we're trying to find x1, but since we're switching the problem to a maximization problem, we change the variables to y's because we don't want to use x and y's, or you don't want to use two sets of x's. That just doesn't make sense. Okay, so max p. Our maximization problem will look a little bit like this. That's our objective function here. 6y1, negative 24y2, negative 24y3. And we now to make our constraints, we do this. 2y1 plus y2 minus 8y3, getting that from this row here, is less than or equal to 10. y1 minus 4y2 plus 5y3 is less than or equal to 4, and remembering that y1 and y2 are greater than or equal to 0. Okay, now to create our ISS, we do kind of the same thing, but we have to put in our subvariables here. So this is what it's going to look like. We need to get our objective function equal to 0. So max p is negative 6y1 plus 24y2 plus 24y3 plus p equals 0. 2y1 plus y2 minus 8y3 plus x1, that is our subvariable, is equal to 10. And then y1 minus 4y2 plus 5y3 plus x2, which is our second subvariable, is equal to 4. And then remembering again that y1 and y2 are greater than or equal to 0. Now, we're going to switch over to this board here. Here's this one right here if you want to look at that. Okay. Now, we need to put this into a matrix. So we're using this and putting it into a matrix, remembering that our objective function goes on the bottom. So up here, we're going to have y1, y2, y3, x1, x2, p, and then right hand side. Sorry, I was doing that wrong. 2, 1, 6, 1, -4, 24, -8, 5, 24. x1, we do have an x1 here, no x2, no p, and that's equal to 10. X1 here, we have no x1 in this one, and x2 here, no p, and that's equal to 4. And then here, we have no x1, no x2, 1 p, and this is equal to 0. So that's what our matrix looks like. Now, we need to find our pivot element. And to find our pivot element, you need to find the most negative number, and this is the only negative number in the objective row. So take 10 divided by 2, and that gives us 5. 4 divided by 1, and that gives us 4. 4 is smaller, so it's going to be in this row and this column, and that means this one is going to be it. Number 1. So then we enter that into our matrices on our calculators, and I already have mine set up. So we hit Program, Pivot, and make sure when you're doing this, you do circle the pivot element and write an arrow, because that's showing that you did the pivot operation. Is it in our matrix A? Yes, so we put a 1. It's in row 2, column 1. Okay, so then this is what we come up with. They're supposed to be dashed, sorry. -19, 5, 54. 1, 0, 0, -2, 1, 6, 0, 0, 1, 2, 4, 24. Okay, so this is what we come up with. Now, we have again our y1, y2, y3, x1, x2, p, and then our right hand side. So here, we read these a little differently. Our x1 equals 0. Our x2 equals 6. And there are no more negatives in the objective function row, so that's why we can figure out our answer here. So x1 equals 0, x2 equals 6, and our min c equals 24. So that means min c equals 24 when x1 equals 0 and x2 equals 6. And that is the final answer.